Good afternoon, all. So we will start our afternoon session. Remaining participant will be joined on YouTube live. So today's topic is CAD CAM with sustainability. Okay. So our resource person is Dr. G. Srikar sir, who is associate professor from Ashoka Women's Engineering College, Kurnool. So I would like to welcome you, sir, in our STTP. Okay, so I will give you command of this session, sir.
Can we start, sir?
Yes, sir.
Okay. Myself, I am G. Srikar, Associate Professor, Ashoka Women's Engineering College, Kurnool, Andhra Pradesh. Okay. I'm going to deal with CAD CAM with sustainability manufacturing. Okay. What is first initially we'll see what is CAD CAM and then what is the scenario in CAD CAM. Then we'll go for SIM and then we'll go for the sustainability manufacturing, which we are going to discuss. Okay. The brief contents with respect to our topics, that is, first initially we'll see what is the introduction of CAD/CAM, then we'll see computer-aided design, what is computer-aided design and what is computer-aided manufacturing, then what is the need of CAD/CAM, integration of CAD/CAM, and then benefits of CAD/CAM, computer integrated manufacturing, scope of CAD/CAM and SIM, elements of SIM, sustainability manufacturing, and sustainability manufacturing with industry 4.0, that is nothing but with IoT basics, that is nothing but computer basics. First initially we'll go for the introduction to CAD/CAM. First, CAD/CAM was initially originated from 1960s itself. Okay, what is CAD? CAD is nothing but it is a software which helps designers and draftsmen, and based upon whatever the design you are given, that will be helpful to manufacture or produce the total process. That is with respect to CAM. CAM will reduce the manpower costs and with respect to the manufacturing process. First, in 1960s, a IBM 360/44 computer was built. First was built for CNC to manufacture the wing of an aeroplane. Then first PC based on CAD system was developed in 1980. That is nothing but AutoCAD. Autodesk only they have done, and AutoCAD is the software which we are using. Presently we are using that only. It was described, first was invented. Then major contributors in CAD/CAM, first is General Electrics and Parametric Technology Corporation after 1980s. Parametric PTC, it is nothing but ProE was invented by Parametric Technology Corporation only. That is the major we have seen for solid modeling or surface modeling or any type of wireframe modeling. We are going to see those modelings also we have done with respect to the ProE or CADIA. All these things we are going to. These two are the first initial major contributors. Then afterwards, later on, there are so many companies there. We are seeing with respect to different number of companies. Initially, after 1980s, they have done these contributions. First, we will see with respect to computer-aided design. Computer-aided design is the usage of computer systems to aid in creation, modification, analysis, and optimization of a design. It is used for creating. That is, if any ideas are there, using that ideas we are going to create. If there is any already taken idea, if you want to modify it. Then afterwards, whatever the idea, we are going to analyze it. There you will be getting the number of solutions. In that also we are going to optimize each and every design. Then advantages, ideas can be drawn and developed quickly. Design can be viewed from all angles within the range of metals. That is nothing but we can do it in any type of view, top view, front view, side view, all these things. some testing and consumer feedback can be done before production itself when it is costliest product. When it is costliest product, we can do some testing and customer feedback also will be taken place. That is done in CAD only. It becomes easier to design and test in and test a range of ideas. That is nothing but easy to design, and what is the range of that idea, that also we can test it. Okay, then going for disadvantages, expensive for setup. Why means initially computers are there and softwares means it is going to be expensive, and needs a skilled workforce, that also we require, and difficult to keep up with consistently changing technology. That is nothing but if you go for Autodesk, simple Autodesk AutoCAD, initial version is somewhat now it is 22 23 version is coming. Like that, improved technology also we can do, and when computers fails, the total setup will be failed. Then next one is computer aided manufacturing. In that computer aided manufacturing, it is called as CAM. It is an application technology that uses computer software and machinery to facilitate and automate manufacturing process. We take the advantages in that CAM. We are going to take an examples as CNC, DNC, flexible manufacturing system, connected with all are connected with computer itself. Those are all computer connected, and it is computer controlled with respect to your manufacturing process. Okay, if you take the advantages, fast and accurate production will be done. Machines can run constantly on repetitive tasks. Goods for producing on mass or flow production line, less material wastage. Why means when you compare with respect to the conventional machining and with respect to computer aided machining, metal wastage will be less when compared with respect to both conventional machining. Disadvantages, again here also expensive and need workforce, skilled workers should be there of engineers, downtime requirement for maintenance, and computers and machines can fail simultaneously. That also we can do it with respect to computer. What is the need of CAD? In this CAD CAM, first we are going to have the need. First, it is nothing but increasing the productivity of the designer, improving the quality of the design. Then communications also should be improved. And with all these things, we need to create some manufacturing database. After creating those database, first we need to create test tool paths and optimize them to help in production scheduling and MRP scheduling models. MRP means nothing but material requirements planning. That is with respect to quality production scheduling only we are going to get. In that we are having the different types of models. Model 1, 2, 3 and up to 4 we are having. Those models we are going to do it. In this we are going to do it with respect to EOQs. Then to have the economic shop floor control, effective shop floor control. That is nothing but if you take it to effective means we need to have that maintenance downtime should be very less. It should be there, but maintenance downtime should be very less when compared with respect to the things. If you compare with respect to difference between CAD and CAM. In CAD and CAM, we are going to see CAD is nothing but it is going to be a computer-aided design, and computer-aided manufacturing is CAM. CAD refers to design or modify the digital model. CAM controls the machine used to produce a part. CAM draws the CAD model to the real world. That is nothing but whatever you are doing with respect to design in CAD, that we are going to give the input to the CAM. Then only that model will be tested. Directly model won't give. We will write the CNC programming, NC programming, and then that programming without errors we should execute it. If there is any errors, we need to retrieve, and there is a programming schedule, and that programming schedule also will be retrieved. That we are going to give to the real world, we are going to give the product. How these CAD and CAM is integrated? First, initially, there will be an idea that is nothing but customer idea. We are going to take it. Those customer ideas will be taken, and based on that ideas only, the design idea will come into the picture. That design idea, we are going to draw it in CAD using any type of modeling techniques. That is nothing but we are going to see wireframe modeling, we are having, and surface modeling, then solid modeling also we are going to have. Those models we are going to, if you see in the picture there, we are having one model. Based on that model only we are going to take it. Then it is sent to the CAM. For what? We are going to write down the tool paths file. For generating the tool path file, first initially we need to go for tool selection. Then what is the machine condition also we are going to verify. From that only we are going to generate the tool path. If there is a tool path file, we are going to verify it, whether the geometry is there correct or not, tool error indication is there or not, the tool path, and any between any number of tools, tool collision is there or not, we are going to do. And then afterwards we'll write down the NC program. After writing the NC program only, we are going to download those NC program and we are going to give the CNC to the CNC machine. Before going to write down this NC program, in the post-processing process only, we are going to write down the NC program with the tool path file only. Those NC program will be given to the CNC machine, and if there is any error with respect to CNC, there again it will be sent back to the CAM. Then if there is no error, then the product will be manufactured, and automatically there will be a finished product we are going to get it. Then what will be the benefits of CAD-CAM? If you see the benefits of the CAD-CAM, improved engineering productivity. Why means conventional? If you see with respect to conventional, there will be a productivity will be less. When you compared with respect to CAD-CAM, productivity will be increased. Based on lead times, that is nothing but a manufacturing lead times. That also will be reduced. Then based on the things here, skilled worker force will be less. Why means CNC machine will be giving the straight away number of products. If you take it with respect to conventional machining, the machine worker should work it on the machine, and then only will be getting the. But here not like that. The personal requirements also will be reduced. Then based upon your customer modifications, we can do it easily. When compared, if there is a customer is there, not like this, I want to redesign, you want to redesign this, since we can do it based upon the customer feedback. We can do some modifications easily in the CAD itself, then it will be produced. Then here faster response will be there. And here one thing we can avoid is nothing but subcontracting. We can, if the CAD-CAM is introduced, then automatically subcontracting of number of items will be reduced. That also will be taken, and transcription errors also minimized. Accuracy of the design will be improved. Mainly in this, accuracy of the design will be improved, and in analysis, easier recognition of components, interactions will be there, and based on that analysis only we are going to do component interactions. And then next one is prototype testing also will be reduced. By means in the analysis only we can do the number of functional analysis. Likewise, if you do it with respect to crash analysis, and if the car is hit, what will be our major crashing analysis we are going to do. That also we can do it in functional analysis, providing analysis to reduce the prototype testing. Why means to reduce the cost of the prototype also we are going to make. And then documentation also will be assisted. Why means all the pictures, all these things will be given with respect to the CAD itself, and with respect to the diagrams also we are going to do. Then designs we can standardize. Here we can designs we can standardize, and we can do it with respect to the CNC. more standardization we are going to do. Then apart of this, group technology concept also will be introduced. Then benefits, better designs are also provided, improved productivity in tool design also we can do it. Not only geometric design, we are going to do it in tool design, and costs will be provided, reducing time for drafting and CNC programming also. I means if there is a similar type of product is there, group technology concept we can apply it, and based on that the part programming will be taken into consideration, and if there is a light modification only we can do it in the NC program. Then errors also we can, few errors will be there in NC part programming, that also we can reduce it and we can identify it. And then existing parts and tooling will be there. More number of tools we can manufacture and we can design it and we can do it. And designs are appropriate to existing manufacturing techniques. Then save material and machine time by using algorithms. Optimization algorithms are there. Optimization algorithms are nothing but we can use TLVO, like that. We are having RSA, then genetic neural networks, ANN, like that. We are having the different types of algorithms. Using that, we can save the materials and we can reduce the machine time. How to reduce those machine time and all, since we can see it in the optimization algorithms itself. And operational results and the status of the work in progress also provided. Then makes the management design personnel on projects are more effective, and assistance.
Excuse me, sir.
Sir,
Slide move or nahi, sir? Not slide, not.
okay, sir. Okay, sir. Okay, sir. Then assistance in inspection also we can do it with respect to your assistance. We are going to do inspection like quality control techniques, quality assurance techniques, all these things we are going to do. If number of parts are manufactured, we are going to use the quality control techniques also. And then lastly, we are going to see for the designers, engineers, and other higher level management and other project groups are given better communication process, and this will give the better communication on all these things we are doing. Then we'll go for the computer integrated manufacturing. What is computer integrated? Actually, the computer integrated manufacturing, if you see with respect to here product design, production, and with respect to business functions we are doing. That is, if you see with respect to the when an organization manage their manufacturing and or production using computers, it is nothing but we are going to see computer. Here managing is also is important. It manages the cost accounting, inventory, purchasing, storage, distribution, and any that is nothing but business functions also is included. With respect to CAD and CAM, we are going to introduce the business functions. Then only we'll call it as a computer integrated manufacturing. This is nothing but here to automate and speed up the production using the SIM. SIM will uses different number of sensors, closed loop process, and many more techniques. That many more techniques is nothing but we are going to use CNCs, DNCs, all CNC is nothing but a computer numerical control. DNC is nothing but a direct numerical. If number of CNCs are there, then we are going to connect it with one computer, that is called as a direct numerical control. And we can use the FMS also, flexible manufacturing system or flexible manufacturing cell also. That is nothing but cells are there more. Then we are going to connect it one system. That system is called as a flexible manufacturing system we are going to see. Sir, slideshow, it is already started. Already with. Sir, is it okay?
Yes, sir. Yes.
Hmm. Mm. Then objectives of sim. Objectives of sim is nothing but lower here will be production cost also will be less, indirectly indirect labor which includes, and then inventory levels also will be optimized, and lower machine downtime, that is nothing but machine lead time we are going to shorter lead times also we can do it, and improving the scheduling flexibility also we here whenever there is a lead time is less, then automatically we can efficiency of the product also we can, then if there is any loopholes are there we can identify it in the production itself, and assisting the management in collecting the relevant data to optimize the efficiency. Then what are the challenges we are going to see? In the challenges we are going to see the production will halt, increase the downtime, employees will be remain idle when the repair work is up to repair work is there, then rise the light time. These are the challenges we are doing. These challenges will be reduced when there is a equal maintenance or there with it. That is it involves storing and manipulating the data as well as the presentation mechanisms. Sim is also includes real-time sensors. They analyze the current status of the work and what will be according to that what the corrective action should be taken. Based on that, there are some algorithms are produced with respect to your process data. Then with respect to that sim approach we are going to do. That sim approach then sim approach. If you see with respect to your what is the scope and what is the CAD/CAM scope. If you see the scope of sim, only design we are going to see with respect to CAD, manufacturing planning and manufacturing control. That is, if you take it with the factory operations, it is divided into 4 types. That we are going to see design will be taken with respect to CAD, and CAM will be taken with respect to manufacturing planning and control. Then sim, it is totally all the process, design, manufacturing and business functions we call it as a sim. Then if you see with respect to your sim, this is with respect to CAD CAM and scope. Business functions will be there, product design will be there, manufacturing planning will be there, manufacturing control. These are all only the factory operations. In the business functions, we are going to see order entry, receivable accounts, all these things will be taken. Whatever the business functions we are going to take it, that includes with respect to your business function. CAD, geometrical models, engineering analysis, design review, and drafting, all these things we are going to take it with respect to CAD. CAM, NC part programming, scheduling, MRP, manufacturing resource plan, and MRP, that is MRP2, and MRP1 is nothing but MRP, materials requirement planning. That also we are going to see in the planning processes. Then in the manufacturing control, whatever the planning we have done, that execution is correctly or not, we are going to check it out with respect to process control. Then shop floor control, then whatever the inventory we are having, whether it is sufficient or not, we are going to check it out. And that also we are going to see with respect to inventory control and quality control. This is with respect to this we are going to take it as a elements of SIM. This elements is nothing but CAM, CAD, CAM, all these things we are going to have. And this we are going to take it with respect to business functions, means not only accounting, with respect to forecasting this, and marketing also we are going to consider, and computer, those are also will be considered with respect to business functions. Then these all 4 will be interrelated, and we are going to take it that is nothing but an elements of SIM. These are all nothing but elements of CAD, CAM, that is nothing but cost estimation also there, CAP is there, then NC part programming, MRP, capacity planning, all these things will come under the CAM. And another in the manufacturing control, those are also process control, process monitoring, computer inspection like CAQC, like that we are having the different computer quality control systems. The operations, those are also will be considered, and we are going. Then these 4 are interrelated, and we are going to get with respect to the elements of SIP. then we'll go for the actually what our thing, that is nothing but a sustainability. That sustainability we are going to take it, and what is actually this, why we are going for sustainability. We are sustainability means whenever any manufacturing process is there, we need to go for sustainable product. For that, sustainability is defined as a measure of degree which the material and social conditions for the human health and environment are maintained or improved over a time without exceeding the ecological capabilities. That is nothing but materials also will be there, social conditions with respect to social conditions with respect to the for human health and environment are maintained with respect to ecological capabilities. That also we are going to, that is nothing but sustainability is usually it's a goal and to achieve the sustainable development. Sustainability majorly it's under the three major conditions we are going to do. One is ecology, economic development, and social equality. Ecology is totally depends upon the environment, what type of environment is there in that organization, that also we are going to take it. And economical development is what type of technologies, what type of manufacturing process we are having, those are also with. Then social equity means what type of persons and what type of people are there, that also we are going to take. If you see the picture, then you will be knowing the three different accepts. One is ecological accept, is nothing but a environmental accepts. Second one is nothing but a economic accepts, sociality accepts. Then these three circles, if you intersect, that is nothing but intersect, then social and economic we are going to see it is a cost, that is socio-economic indicators. Then economic and environmental, if you connect it, then you will be seeing the eco efficiency indicators, that is nothing but a wastage. Then social and environmental aspects, if you intersect, there you will be getting the socio-economic indicators. Then if you match these three, there we will get the sustainability indicators. Sustainability indicators are nothing but energy we are going to take it, materials we are going to take it, environment, that is nothing but what is the air pollution we are going to take it, pollution dispersion also we are going to consider. All these things we are going to consider with respect to the environment, both all the intersect. That is nothing but where economic, social related and environment related all conditions will be there with respect to sustainability. Then with respect to with respect to the next thing is nothing but this, if you see with respect to the economic aspects, those economic aspects will come under our technology. Why means in the previous slide only we have taken economic development is by technologies. Those nothing but we are going to take it economically. It is going to be taken with respect to the engineering process. Engineering process generally occupies the economic development portion of the spectrum. These economic development will be driving two factors majorly in the two or more driving factors. That is with respect to manufacturing process, we are going to take it material, economic and energy consumption. The main purpose of sustainability study in the manufacturing process is to restrain material consumption and renewable energy consumption. That is the major process we are going to do it in sustainability study in with respect to only the manufacturing process, not with respect to other conditions. That means we are not going to take the sociality and we are not going to take the environment. I'm going to take only the economic aspects only. I'm going to take it. Those things mean we are going to see what is the material consumption and what will be the energy consumption. In that we are going to, in generally sustainable manufacturing requires a study of sustainability in manufacturing process. If you take it sustainability manufacturing is denoted with SM, or we'll call this as sustainability manufacturing is also called as general green manufacturing also. It can be defined as a method for manufacturing that minimizes waste and reduces the environmental impact also. That is also there with respect to manufacturing ఒకటే చూసుకోకుండా, that is if you see not only manufacturing process, we will be seeing the waste environmental impact also should be reduced. That also we are going to make it with respect to the manufacturing process. These goals ought to be obtained mainly by adopting practices that will influence the product design, process design, and operational principles. Okay, sustainability in manufacturing is also with respect to product and process design. We are going to define it, is also defined as the system that integrate product and process design issues that we are going to see with respect to the sustainability. Only the product and process related conditions only we are going to see, and those are interrelated, then it forms a sustainability manufacturing. These sustainability manufacturing, we are going to make it, and we are going to have the SM we are going to do. Then sustainability manufacturing, there we are going to have the what is product innovation, what is the process innovation, and what is system innovation. That three devices and three process, major process, that only if we take it with respect to products, sustainable materials for products, advanced product design, effective product assembly or recovery, design for reuse and remanufacturing, modular and reconfigurational design, design for improved performance. If you take it with respect to the materials of products, sustainable, what are the, which for that product, which type of metal is useful and which type of material is identified. If previously for preparing for manufacturing of mudguards of the two-wheeler vehicle, initially they are used the aluminum sheets. Now they are using the plastic. That is nothing but it is replaced. Whenever previously whichever metal is used, and now whichever it is cheaper and whichever is lighter, that they are going to take it into consideration. That is the material which is sustainable, that we are going to take it. That is, we are going to replace it with respect to based upon the cost and based upon the usage also we are going to do. And product design, if you take it with respect to the Kawasaki Bajaj, if we take the example, Kawasaki Bajaj is taken first. Initially there is a huge type of first primary front in the front, from the front view, lights and all these things like somewhat awkward. Then now it was taken as a Bajaj CT100. Then it was effective and the design has been changed and it is used. Then whatever effectiveness we are going to take it, we can do it with respect to reverse engineering process or recovery we are going to use. Reuse and remanufacturing also we are going to do. Modular and reconfiguration design also we are going to do. That is nothing but from the product to the design, what he has done, what is the process we have done, that we are going to identify, and we are going to do it for reconfigurable design we are doing. That is designed for improved performance. Then process innovation, sustainable process, advanced process technologies, integrated process, improved process performance. Process means different types of process. We are going to have the process layouts we are having, layout performance also we are going to do. If there is a layout, functional layout, process layout, product layout we are having, those things also will be introduced with respect to the process, and which type of process is sustainable, for which type of manufacturing process we are going to do. Those are all we are going to take it, and we are going to use those process, and we are going to identify that we are going to use it for innovation of the process. And based upon the technologies, which technology we are going to use, advanced technology we are going to use it for technologies, those processes are integrated, and we are going to improve the performance. Then at last we are going to have this system innovation. System innovation, it is nothing but the system means it's going to be taken with respect to overall organizational level. And then there we are going to have the environmental conditions, there we are going to have the economical conditions, all business level conditions, then what type of marketing we are going to give, and what type of supply chain, that is marketing with respect to how it is going to be sold. All these things will be taken with respect to systems. That is enterprise level system integration we are going to do. Then supply chain integration also we are going to do. Then next topic is nothing but we are going to see with respect to sustainability manufacturing. With respect to sustainability manufacturing also, we are going to have some issue. If there is an issue in manufacturing planning and control in such a manner to identify, quantify, assess flow of environmental waste. What type of assessment we are going to do, we are going to see all these things, we are going to assess and then manage the flow of environmental wastage. The goal of SM is reducing the environmental impact to that of self-recovery capability of earth, deals with to maximize the resource efficiency. That is nothing but materials also we are going to do. That materials may be with respect to the earth efficiency. There to reduce the maximum resource efficiency also we are going to do. The tool generally used to implement in SM sustainability manufacturing is life cycle assessment. How LCA is going to. That is LCA we are going to see with respect to the methodology we are going to see with respect to LCA. NCA, first we are going to see raw material will be acquired and that raw material will be taken, and if there is raw material, then we are going to take the material should be productive for production. I mean that raw material we cannot use it for product manufacturing. There is certain manufacturing process will be done, and to produce those material, then that material only will be taken and we are going to use for product manufacture, and it may be used and final disposal will be done. This is the process we are going to do, and in this process each and every phase will be having the energy, emission and wastage also will be. Those each and every phase will be having the total costs. There we are going to have the energy. Why means if you take the raw metals, you are going to dig it, you are going to spend some energy, and there will be some emissions, environmental emissions also will be there. Then there will be some wastage also with respect to that product. Then if you convert that metals to the useful product, useful material product, then after that also there will be some wastage. Then environmental conditions, save energy, then what type of energy you are going to use it, that also we are going to take it into consideration. Then those metals are used and we are going to manufacture the product. If you manufacture the product also, we are going to use the energy and emissions in wastage. Then that product, then at last we will be getting the final product. That final product, whether we can use or not. If it is not reused, then it is sent to the use. Then again, there is one more loop also is there. There is a product side recycling. Something, if you see it with respect to the recycling process also, we can do it in some metal. That is nothing but if you see plastic bottles. Plastic bottles, what they will do, they will whatever the plastic bottles are there, they will collect it, and again those things they are going to make it a raw product, and then again they will be preparing the plastic bottles for cool drinks or for water. All these things they will be using those. That is the product recycling also will be done. This phase we are going to do it in 3 different phases. Okay, these phases also we can send that product recycling to the metals first initially, or otherwise directly if there is a product that bottle is used, if it is that is in that condition, glass bottles we can use that, and then automatically it is used for product manufacturing, then it is sold. Like that wise we are going to use it, and we are going to, this is nothing but a LCA, that is nothing but life cycle assessment analysis we are going to. Then and the sustainability manufacturing should integrate the sustainability activities at all levels of manufacturing products. we can use in sustainability 6 hours we are going to use. What are those 6 hours are nothing but we are going to see rethink, refuse, reduce, reuse, repair and recycle. These 6 hours. Apart to this, there are so many hours also is there. Mainly for sustainability, these 6 hours are mainly used. Those 6 hours we are going to see, and with respect to these 6 hours only we are going to see. And that is with respect to your diagram. 6 hours is rethink. First, we'll rethink the what is the product we are going to see, and we'll use whether it is used or we can use it or not. We are going. If it is not used, refuse. That is nothing but you straight away throw into the dustbin and we can use it. We cannot use it. Then if we can use it, then there how much quantity we can use. If you use, reduce it. Reduce those quantities and then we'll use the reuse process. If there is a condition, if you want to repair it anything, we can repair it and then recycle. The priority is comes from down to upper. That is nothing but recycling case. Recycling, repair, reuse, reduce, refuse or rethink. Okay, this is the higher priority from the down to the up. We are going to do. And why means we are going to see the recycle first. For this example is nothing but water bottle. We'll buy the water bottle and we'll drink it with the water bottle, and then if we are using actually in that on the bottle itself we will be seeing don't reuse. It is recycle. If there is a recycle, throw it into dustbin like that they will tell. Then we'll throw that. Then if there is anything repair is there, we'll repair it. And if it is reuse. If that reuse is not there, reduce it. And if it is not, if anything faults are there identified, then refuse it. Then rethink which we are going to use it. That is nothing but refuse. Make a product redundant by abandoning its function or offering the same function with radically different product. Rethink, make the product use more intensive by sharing the product. Reduce, increasing efficiency of the product manufacture or use by consuming fewer natural resources and materials. Reuse by another consumer of discarding product which is still in good condition and fulfills its original function. Repair, it is nothing but repair and maintenance of defective product so it can be used with its original function. Recycling means process materials to be obtained is going to be recycled or lower grade quality we call. That is nothing but then if you use the bottle, the same bottle, we will be using the lower grade only we are going to see. Then based upon these 6 hours, these 6 hours are derived from the 3 P's. Okay, so for sustainability, 3 P's, 3 hours, 6 hours are very, very important. With these only, their only manufacturing process only it will be recovered. Okay, those that 6 hours of sustainability are derived from the concepts expressed by 3 P's of sustainability. What are the 3 P's? 3 P's are nothing but people, it is social responsibility, profit, it is economical responsibility, planet, it is nothing but environmental friendliness. These 3 people, planet, profit, and people, we are going to see. We will see in detail about the 3 P's. If you see, the planet is the first P. The planet is the first P. Second one is nothing but a profit, and third one is nothing but a people who are going for sustainability development. These P's are very, very important. Then if you see it for planet is environmental sustainability. Consider the environment in business strategy. Switch over to renewable. Now all the companies or all the colleges, they are going for renewable energy sources. That is like solar cells, solar power, all these things they are going to use. That is switching over for renewable energy sources. Then choose the local suppliers. Then be more efficient for leveraging the digital transformation, pursue eco-friendliness design and production. That is nothing but mainly we are going to for sustainability. We are going to do it for eco-friendliness design and production. We are going to. Then the second one is nothing but a profit. Profit is nothing but a eco-friendly economic sustainability. Economic sustainability means whatever the profits we are going to get, that it is to survive. That is, a business needs to be profitable to survive. Making a profit is an indication that the business is delivering something valuable. That is nothing but more valuable only. If it is there only, then only the profits will come into. Then but the pursuit of profit should not come by neglecting the environmental issues and the social issues. That is nothing but here the main thing economic is nothing but we need to consider environmental issues and the social issues also we are going to consider, and we are going to maintain those profits with respect to the with respect to these issues only we are going to maintain. Then last one is nothing but people. People is nothing but a social sustainability. Social sustainability, a organization should be respect the right of employees, offering working conditions to everyone, involving in supply chain, like that is nothing but working times. All these things we are going to consider. Promote the well-being of employees. That is nothing but the employees. What contributions, what are these things? All we are going to consider and we are going to do and contribute to the improvement of all overall living conditions in the local community. All these things you should consider the surrounding considerations with respect to the organization in the environment, and approval and support of this society is an asset for long-term success of the business. That is nothing but if you are going to do all support from the employees and with respect to from the society, all these things we are going to consider and we are going to get the long-term success of the business. Then sustainability with sustainability manufacturing with industry 4.0. Now the industry 4.0 is coming to the picture. That is 4.0 is nothing that we are going to see how the technologies are going to be and offered. As sustainability manufacturing itself, it is elusive and hard to define. To conceptualize and to analyze for various perspectives depending upon their purpose, dimensions and applications. Depending upon the purpose and the dimensions and the application, we are going to define the sustainability manufacturing, and it requires a degree of integration and collaboration, scenario planning and process innovation in the value chain for adoption of sustainability manufacturing initiatives. All under these circumstances, industry 4.0 technologies may offer existing opportunities for addressing the challenges of sustainability manufacturing, the factory and as well as value chain. Value chain is nothing but a business level chains that is we are going to see. Despite of these regulations, they struggle to answer the question: how can industry 4.0 and underlying digital industrial transformation contribute to sustainable manufacturing? All these things, that is nothing but the hierarchical model will gives the explanation of their how industry 4.0 can contribute to sustainable manufacturing. This is nothing but we are going to have the industry 4.0 with respect to sustainable manufacturing. If you see here, all these things we are going to have the sustainable with respect to your sustainability manufacturing, sustainable economic growth, renewable energy sources and manufacturing sources, and this is to the right hand, to the left side we are having the technologies with respect to the computer, artificial intelligence, IoT, blockchain, big data, robotics, all these things. Then components are nothing but smart customers, smart factories, smart houses, smart holders. All these things will come, and principles with respect to real time decentralization. All these things these are all interrelated with respect to technologies, components and principles are interrelated, and these interrelations we are going to take it, and with respect to these interrelations only with respect to we are going to have, this is nothing but a industry 4.4 technology. This is nothing but a industry 4.0. We are having the technologies, components and principle. It is nothing but industry, and we are going to have the industry sustainable 4.0 functions, that is business model innovation, customer oriented manufacturing. These are all we are going to have the with respect to market, business, and with respect to environment, and with respect to cost, all the environmental conditions, all the product development conditions, all we are going to get with respect to the middle level product. Then after this, sustainability manufacturing will arise. That is with respect to industry, that is nothing but a computers, and we are going to innovate with respect to sustainable manufacturing. All these things we are going to get, and we will be getting the final product. That we are that final product only we will be giving, and that includes your sustainability. And thank you for giving this opportunity. Any questions? Sir?
Participant, if you have any questions, they can ask.
I think there is no question from participants. Sir, can you share this PPT?
Okay, sir, I will share it to you.
Okay, okay. So that I will send it on WhatsApp group. There will be no question from participant. So we will conclude this session. Okay, thank you. Thank you so much, sir, for giving your valuable time for this HTTP. I hope all participants definitely get beneficial from your valuable knowledge. And so thank you, sir.
Thank you, sir. Thank you.
Okay.